Dr. Chuck, the science schmuck.
Synchronize. So this is a little bit of a weird one in that it's not accomplishing any critical scientific task or doing anything I even need to do done. Get done? Do done. Anything I need to do done. This doesn't do any of that. But it's based on an idea. An idea that I had that I probably shouldn't have had that isn't helpful, but intrigues me. So I was looking at my pressure cooker the other day. I forget, it was during the wood. I was making the saltwater wood to make it sink in the pressure cooker. And it occurred to me that there's a nub. One, that makes this an efficient weapon, slapping people with it. You can also use that end if you only want to kill them slightly. I can't kill people because of the first law of robotics, but this is a sealed pressure vessel which a liquid can be put in, where the only primary outlet is this one small nub. And that got me thinking, I could use this thing to produce a gas that could then be condensed and distillated. I can use this to distill. Now you're saying, oh, he's going to make alcohol. No. You cannot use this process to make alcohol. Distilling alcohol in any way for any reason is super duper illegal. I could have 10 machine guns in here and it would be not as illegal as making my own alcohol. What I'm going to be distilling instead is water, which you may be asking, what's this bucket full of? The answer is low. It's full of low, from Lowe's. Ooh, it's slippery. In actuality, this is full of water. And you may be saying, but that doesn't look quite like normal water. Doesn't taste like normal water either. That's fish tank water. And not just water from my regular fish tank, that's from my saltwater fish tank. The anemones were having a little bit of a problem in that they were getting sick, so I changed the water. And this is what came out. Used saltwater fish tank water. Ugh. Not only is it full of salt, it's also full of contamination with substantial cyanobacteria. You wouldn't want to drink that. You'd get very sick. I'm going to try to distillate the water. Distill it? Distillize. I will distillize this water using probably this into drinkable water, which I will then drink and hopefully not die. So how is that accomplished? Well, the first part is that the water ought to be loaded into the vessel. The vessel in question being the pressure cooker. Ugh. This water is weirdly stiff because it's gross, kind of yellow, salty water. Avoid getting this on anything metal or electronic unless you want it destroyed. Okay, that's not nearly the whole bucket's full, but it's a goodly amount that we can start with. I will then affix the lid. Eventually I will fix the lid. I fixed the lid. That actually took me like 10 minutes. Closing that seals the pressure vessel. Now I have this nub. On a normal pressure cooking situation, you put this on. It's a valve. It holds the pressure in and sort of jiggles to let the pressure out so the thing doesn't explode. In this case, I have a piece of vinyl tubing that leads into this steel bowl, which was then filled with water and frozen in my freezer to produce ice. So there's actually a coil of this PVC vinyl, it's not PVC, it's vinyl, tube in there, which should be sized to fit right on the end of the nub, meaning that all off-gassing pressure must go through this tube in order to escape You may say, isn't that putting a lot of pressure on the pressure cooker? The idea is that if the pressure on this gets so great that the pressure cooker risks exploding, that'll pop off the nub. It's not held on very tightly. I can pull it off with my fingers. And then it'll just release steam into the air. It'll be loud and scary, but it won't explode theoretically. I then take the output and I put it in this jar, which will collect. The theory being that when the water is heated, the water will boil, producing steam. The steam will not be able to escape this vessel except through the nub. The steam will escape through the nub, move through the tube, go into the coil in the ice. The ice will be in thermal contact with the tube with the addition of a little bit of water. This is not full of coffee. This is full of coffee. The steam will condense into water. It will then be forced by the pressure to continue through the tube and come out in the jar. Now it's just a matter of waiting for this thing to actually heat up. Hopefully it doesn't melt or explode. Just in case, I'm going to avoid being near it. Alright. Well, this is interesting in that it appears to be working. I had to turn up the hot plate all the way up, which reignited a lot of the spilled rosin that was on it. So it's a little smelly, it's a little melting, but it didn't explode. And it appears that it is currently distillating. However, it is important to note that it's also steaming on the output, which is not ideal. That means that it is not cooling down enough through here. The coil is either not conductive, because I should have probably used copper, which is very highly conductive of thermal energy, or the coil is not long enough. However, steam is being ejected from this hole at some degree, forming water as it passes through the tube, cooling down somewhat as it goes through the process, and emerging out in this jar. We're driving a car around here. The jar is actually quite hot, which is probably not ideal. Now in this case it would probably be efficient to cool down the jar, but at this point it's too late. I've already made that mistake too many times. If you take a hot jar and put it in cold solution, it'll just snap because of the internal tension. The water is cloudy. Still steaming, it's relatively warm, but I've let it cool down a little bit so that I can taste it. Because I will not be able to validate if the distillation worked unless I taste this distilled saltwater fish tank water, which looks very cloudy and does not smell good. Oh well, for science. Well, it's not salty. That's definitely true. However, that horrible smell that I thought was this thing burning is actually the water. It tastes like burnt plastic. Not even like the good burnt plastic that smells like burnt, like chemicals. It's that vinyl tube. Part of that vinyl is now inside me, because I swallowed. Probably shouldn't have. But I have at least confirmed that you can remove the salt. Not in any sort of energy efficient way. That's why we don't do this in areas that are near the ocean that don't have water. That's the primary reason why distillation is so troubling. Yes, we can turn seawater, in this case artificial seawater, heavily contaminated with a lot of anemones, into relatively drinkable water. I mean, this does not taste great, but if I was desperately thirsty, this would be fine. I'd glug this down all day and night. However, it's not actually any more efficient to make it this way than it would be. This just isn't practical. Meaning primarily that the amount of energy put into this to make this tiny amount of foul-tasting water is much greater in cost than it would actually be to buy fresh water. I mean, this ice is made of fresh water. I could just drink that. Oh, I feel sick, which is probably bad. So that is all I have for that, and I might need to vomit at some point. But it does prove that distillation is possible with homemade items. Do not put alcohol in it. Extra.